Hey everybody, welcome to another edition of 4.1 Notes. This time around, I'm just focusing on simplifying radicals though, and simplifying radicals when they're involved with fractions. So we're going to have to rationalize the denominator. So before we get started, let's recap what it means to do the square root method. I need my x squareds on one side. So I'm going to minus this 2/3 x squared to this side. And 4/3 minus 2/3 leaves me with 2/3. So I have 2/3 x squared equals 6. And now we have one fraction. Get rid of that fraction, flip it and multiply. So I'm going to multiply both sides by 3/2. And 6 times 3/2, 6 times 3 is 18. 18 divided by 2 is 9. So what we have here is says x squared equals 9. And now that you've gotten it down to x squared equals something, square root both sides, and you get x equals plus or minus 3. Don't forget to do that plus or minus anytime you do a square root. Okay, so let's talk about simplifying some radicals. Alright, so this would be like at the last step, you get your answer as square root 80. Well, how would I simplify that? Well, you got to think, what are your factors that multiply to get 80? We could start with 80 and 1, but that's not really helpful. 45 and 2. Oh, let's see here. There's like 10 and 8. 20 and 4, and 16 and 5. Alright, hopefully I didn't miss any, but I think that's all. So what you want to do is you want to look for your perfect squares, meaning your perfect squares 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, so on. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on. So is there a perfect square that's a factor in these? So there's not a perfect square in 80 and 1 or 45 and 2 or 10 and 8, but there is in 20 and 4. 4 is a perfect square. And there is in 16 and 5. So what you want to do is you want to use the one with the bigger number. You know, it's almost like greatest common factor stuff. So I'm going to rewrite square root of 80 as the square root of 16 times the square root of 5. Alright, I can take the square root of 16, that's 4, and the square root of 5 would stay behind, and then don't forget your plus or minus. And then you can always double check it by typing in 4 square root 5 in your calculator, and then square root 80 in your calculator. They should output the same number. But yeah, that's it. If you'd use 20 and 4, 20 could be simplified some more. So that's why you want to go with the bigger number. So here's what 20 and 4 would look like. So square root 20 times square root 4. Well, square root 4 is 2. And so it would say, and then square root 20 is 5 times 4. So then now I do the square root of 4, which is 2. So I have square root of 5 times 2 times 2. And so that ends up getting 4 times the square root of 5. So we got the same answer, it just took longer. Okay. Yeah. So here I have a fraction. Oh no, fractions. Well, if it's all under the fraction, it's like saying this. Square root of 64 over the square root of 9. It's like the same thing. Well, the square root of 64 is 8. The square root of 9 is 3. And then don't forget your plus or minus. And that's the final answer. So what about this one? 490 over 16. Well, let's see here. The square root of 490. We don't know what that is yet, but I do know the square root of 16 is 4. You know, plus or minus. I'll put that on all my steps. Think about it. 490 is 49 times 10. So I'm going to write square root of 49 times square root of 10. And by the way, it doesn't matter if you write 49 times 10 or if you write it separately like that. It really doesn't matter. Square root of 49 is 7. Square root of 10 is square root of 10. It doesn't simplify. So I'm going to say my final answer is plus or minus 7 times square root of 10 over 4. And that's as simplified as it's going to get. This next one, 3 over square root of 100, well, I don't know what the square root of 3 is, but I do know the square root of 100 is 10. And so I just throw a plus or minus on there. That's it. That's all there is to that one. So, why don't you try these next 3 examples? So pause the video, and then I'll give you the answers once you unpause it. Okay, so for this first example, I split 200 up 100 times 2. 100 would be the biggest perfect square. 10 squared is 100. So square root of 100 is 10. Square root of 2 stays behind, so I wrote plus or minus 10 squared 2. 25 over 16, square root of 25 is 5, square root of 16 is 4, so I said plus or minus 5 over 4. Excuse me. Square root of 500 over 81, well, I wrote square root of 500 could be written as 100, square root of 100 times square root of 5, and the square root of 100 is 10, so I had 10 times the square root of 5, and the square root of 81 is 9 over 9, and then I wrote the plus or minus. Alright, so let's talk about rationalizing the denominator. I wrote right here, you can't have a square root in the denominator of a fraction. So let me show you what I mean. If x squared equals 64 over 3, then x is going to equal plus or minus the square root of 64 over 3. And that can be simplified. That can be square root of 8 over square root 3. Why? Because square root of 64 is 8, and the square root of 3 wouldn't simplify. So that would be the answer, only this, you can't have the radical in the denominator underneath on the bottom of the fraction. So how do you get rid of that? Let's talk about that. So you have 8 over the square root of 3. This is how you get rid of it. Take whatever it is on the bottom and multiply it times itself over itself. So why are you doing that? Anything divided by itself is 1, so you're multiplying by a 1. And 1 times anything is itself. 4 times 1 is 4. 10 times 1 is 10. So 8 times 8 over the square root of 3 times square root of 3 over square root of 3 is still going to be 8 over the square root of 3, but it's going to look differently. This is what I mean. This is squaring a square root. What does that mean? It just means you're going to get that number that's inside. So my final answer is 8 over the square root of 3 times 3. And then don't forget your plus or minus. Okay? That's the final answer. So that might be a little confusing. So let's keep moving. And hopefully it'll make a bit better sense in a little bit here. So I have x squared equals 25 over 27. So I'll square root both sides. And so we got to think about what's the square root of 25 and then what's the square root of 27. Okay, so the square root of 25 is 5. And the square root of 27 can be simplified. So I'm going to write square root of 27 is 9 times 3. Okay, because 9 times 3 is 27. Why did I choose 9 times 3? Well, besides 27 and 1, 9 and 3 are the only two factors of 27. But 9 has a square root, and that is 3. So I'm going to say the next step is 5 over 3 square root 3. Okay, and let's not forget our plus or minuses. Okay, so now I need to rationalize that denominator. So again, by rationalizing it, it means find a way to get rid of that square root number. So I have the square root 3, so I'm going to say 5 over 3 square root 3 times the square root of 3 over the square root of 3. So these two are going to make another 3. So this is 5 square root 3 over 3, and then this is all multiplying, so it's 3 times 3. So what's 3 times 3? 3 times 3 is 9. So the final answer is plus or minus 5 square root 3 over 9. Alright. Let's do the next one. So I have 2 over 5 times x plus 3 squared plus equals 5. So I got something on the outside of my parentheses, so get rid of it. Flip it and multiply. So 5 over 2, and then I'm going to times it by 5 over 2 over here. So that's going to leave me with x plus 3 squared equals, that's going to be 25 over 2. Alright, so now square root both sides, and that's going to leave me with x plus 3 equals, the square root of 25 over 2 would be, square root of 25 is 5 over the square root of 2, plus or minus, of course. So let's rationalize that 5 square root 2. So I'm going to say 5 over square root 2 times, well, I have a square root of 2 on bottom, so I'm going to do that times itself, or divided by itself. So that's going to be 5 square root 2 over the number 2, plus or minus. So let's plug that back into our equation. So this, I'll place it in there. So I have x plus 3 equals plus or minus 5 square root 2 over 2. So I just need to get rid of that minus 3, or that plus 3, so I'm going to minus 3 over. So we usually write that number first, so I'm going to write negative 3 plus or minus 5 square root 2 over 2. And that's the final answer. You could type that into your calculator, negative 3 plus 5 square root 2 over 2. Press enter, get that, and then negative 3 minus 5 square root 2 over 2. Press enter and get that answer. But yeah, that's basically it. So I gave you 3 examples to do on your own. So why don't you try those right now? Okay, so on this first one, square rooted both sides. Square root of 81 is 9. So I wrote plus or minus 9 over the square root of 5. And I rationalized it by multiplying square root of 5 over square root of 5. So that got me 9 times the square root of 5 over just the number 5. And then I just said x equals plus or minus that. The next one, a bit more challenging. Square root of 64 over 300. Well, the square root of 64 is 8. So I started off by just writing 8 on top. And then I split up to 300 as square root of 100 times square root of 3. Alright, so the next thing I did was I square rooted 100, which is 10. So I have plus or minus, make that look a bit more like a plus sign, 8 over 10 square root 3. So now I just need to get rid of that square root 3 on the denominator. So I took it and I multiplied it by square root 3 over square root 3. So I have 8 square root 3 on top, and then that leaves me with 10 times 3 on the bottom. Alright, so that just leaves me with a final answer of 8 square root 3 over 30, plus or minus, of course. So yeah, if you have the number on the outside and then you're squaring the square root of the same number, it'll just become like 10 times 3 in that one. Like, yeah, that's okay. I don't want to over-explain it, so I just stopped talking. Okay, so this one was admittedly pretty difficult, so if you got it right, good for you. I flipped it and I multiplied it by 4 over 3, so that got me 40 over 3 on the right side. And so when I square rooted both sides, now I need to simplify the square root of 40 and the square root of 3 on the denominator. So I have x minus 1 equals plus or minus, so I wrote square root of 4 times square root of 10 instead of square root of 40. The square root of 4 is 2, so my next step here, I wrote 2 square root 10. Okay, see, I didn't change anything else except I just took this and put that right there. The next thing I did was rationalize that denominator. So I multiplied the square root of 3 times the square root of 3 over it, you know what I mean. So that's going to give me 3 on the bottom, but it's not going to get you 30 on the top. It's going to get you the square root of 30. The square root will still be there if the number's different. So this is what I mean. See how I wrote 2 times the square root of 30? Because the numbers were different. The square root symbol would go away if they were the same exact number, which is why you have just the number 3 on the bottom there. So that's kind of an important detail. And then all I had to do after that was add 1 over. So I got my final answer as 1 plus or minus 2 square root 30 over 3. Okay, so if you're one of my students, I'll put a QR code or a link right there. And that's your code, and just log in and do that assignment. Okay, bye everyone.